Punters are without a doubt the most overlooked players on the football team. While their work might not be as flashy as a wide receiver or a cornerback, their behind-the-scenes work can make or break a game. All right. Today we're going to go over football punting, and more importantly, the physics behind it. There are many physics concepts that apply when punting a football. Let's go over them. But first, in case you didn't already know, here is how you punt a football. The snapper snaps the ball to the punter. The punter then catches it, puts it in front of him with the laces pointing up. If you are the punter, you want to hold the ball straight ahead of you with the ball pointing towards 11 o'clock. Once you catch the ball, you take 2 steps forward before dropping the ball. You are going to hold the ball with your dominant hand and then drop it. Once you drop the ball, do not hesitate to kick it. Kick it immediately after you dropped it. Drop your dropping hand to your side after you make contact with the football. You want to make contact with the ball with your laces when the ball is around your knee level. Most importantly, finish through with your swing. You want to swing your leg through the ball as high and as powerful as you can. There are many different physics concepts that can apply to punting. The concept of gravity. What goes up always must come down in gravity. When I punt a football into the air, it will stay in the air for a certain period of time, and then it will come back to the ground because of the force of gravity. The concept of the law of physics. The law of physics causes objects to follow a particular path when launched. This law can be applied to punting because when I punt the ball, it is set to follow a particular path. The concept of potential energy and kinetic energy.
When the ball gets to the top, its potential energy is at its peak, and then it starts going down until it hits the ground. When it hits the ground, the kinetic energy reaches its peak.
The concept of projectile motion. Projectile motion occurs when an object is projected by a force that stops exerting influence in the object after it has been launched. The concept of projectile motions applies to punts because the foot strikes the ball and immediately the force of my foot stays pushing the ball without my foot actually being there. These are the equations you have to know. The equation for air resistance, the equation for hang time, and the equation for distance. The equation for horizontal range, also known as distance of the ball, goes as follows. R equals VO squared sine 2 theta over 9.8. The equation for hang time goes as follows. T equals VO sine theta over 4.9. The ball's distance and hang time can be affected by air resistance. I always try to punt my balls in a spiral motion. Punts should be in a spiral because that makes them flatter, and when it is traveling in the air, it will avoid air resistance better than if it were punted in a chaotic manner. Also, spirals are better because of angular momentum. The pointy ball can travel in a straight direction rather than all over the place when you punt the ball wobbly. A punter's leg should be at about 45-degree angle when striking the ball. When a punter strikes the ball at a 45-degree angle, he is more likely to get more hang time on the ball. You may be wondering, how does wind help me punt? Having wind at your back certainly helps you. Take a look at the world record punt from Steve O'Neill. Steve O'Neill had a 98-yard punt, but why did it go so far? O'Neill's 98-yard punt went very far because it was a good kick. However, he had plenty of wind in his back. With the wind, the ball was carried even further than it should have been. This has been Andre Mazur with the Physics of Punting. Thank you for watching.